Yes, we are live. So we can discuss the PCB changes we made and your PCBs. Basically, I fixed all the bugs in my PCB. Luckily, I had done the layout and the
Oh, the bug.
schematics, uh, st- schematics, so that it was easy to fix the bugs. So I'll show you what the problem was. Mm, yeah. So these are the level shifters. So you see, I have tied them to 5 volts.
Yeah.
So this VCC-B is the 3.3 to 5 volts output. And so when you tie it high, and if there is nothing here, it will try to pull it high. So as soon as you power this on, these pins would go all of the pins on the Arduino or the board side, uh, tumbler board side would go high. And I don't know how the
Mhm.
bootloader has been done for the ESP32, Arduino ESP32, but it takes like 1 second to boot up, and then it would already be starting to run. So I realized that I have laid it out so that if I cut this uh, 5 volts here in between, none of them would get 5 volts.
I'm sorry.
So
Can
that
you
is what
say
I
that
did.
again? You set it up that if you cut the 5 volts.
Yeah, I had laid out the board so that it would be easy to cut. But yeah, that was not intentional. I had just laid it out. Luckily, in a way that it was easy to cut it out. So basically, I made a cut here on this line. So the battery, so it cuts here. Yeah, the enable here, and then I just put a switch between this pin and this battery. So there is a capacitor here. So that also was a little lucky. That the capacitor, I put a 0604 capacitor on it, and then yeah, it was easy to put the wires on the pad of the capacitor and the
What does
pins.
the
So a
capacitor
lot of
do?
what?
What does the capacitor do?
It's a decoupling capacitor. It's just um decouples the like the battery voltage high and low. Uh, Technical part of it, you can search it. Just search for decoupling capacitors. You'll find it is these ones. Yeah. So I made a cut here and put a switch in between, and this is how it works. It
So the idea is, like, how does the switch is like a switch that you push?
Yeah. So now to power on the board for the entire system, you have to press two switches. The one that is on the battery, so it will immediately. So I have not cut the powering to the Arduino itself. So I only cut the 5 volt generator that is going to the level shifters. Did you get it? So the when you power on the batteries, the Arduino would boot, but the level shifters won't be like driving the 5
Active.
volts high.
Yeah.
Yeah. And then once the Arduino is booted, then you can press the switch to bring the level shifters online. So there are now two switches.
So effectively, that's the motor cut switch. Like the Arduino still runs, and you can tell it whether it should be moving or not.
Yes. Yeah.
Well,
One of the
we read about. No, please.
I was just going to say
Because
that
we talked about this soft break. Remember?
it was a soft
Yeah, I
break.
was just showing how it looks now. So yeah, and then it's just a switch in between those two pins. So if I turn it on right now, this is because the switch is already on, so it will run. But let's say if I turn it off, and then so now it will not run, and now the whatever the software is supposed to do, you can start from here.
So it works. I
Yeah,
was
the software still has to be done, so that is still some work.
I was mentioning we talked about the soft break mode for these motors, where you short one wire to another, which prevents the motors from moving. So you could like directly control the motors.
Yeah, but even for that, the ESP32 has a boot up.
No, you put it in a default locked, and you have to. I don't know what is it called.
Yeah,
You
but
have a
right
switch
now,
that you
yeah, that
control,
would
and when
take.
it's
You could do
moving,
it. Yeah. So basically, if you wait, so which is the I forgot the. So there is a pin, I think, going to the motor control.
you make it a bit
I think
bigger.
it was A in or something. So could basically cut that. Yes. So I think it is this A in one. So D7 and B in one, D12. So what you could do one way is make them low, D7 and D12. But then that would require more soldering. You could actually do it.
Because you would have to update
Then
the motor control board itself, not the.
no, the plug-in board can also be done so that I instead of cutting this, I keep it on, but yeah, basically you'll have to put two more switches. Yeah, it's more work. Or you could have a pull down resistor. Yeah. So basically, if you have a resistor from this line, where is this? D7. D7 is going to A7. No, yeah, here. This one. Uh, D7 and D12. I think it was Mozi. So if you put a pull down resistors on both of these, so by default they will go to ground. But yeah, it's still no. Yeah, it will take a lot of soldering. That pull down won't work because it's still pulled high. So yeah, I think this is the only way which I did, at least without much soldering.
Hmm.
And that was a series of lucks that I laid it out in such a way, and the decoupling capacitors were there. So
So are you going to have a replacement board printed?
Yeah, I'm not sure. I know all the bugs now, so basically it would be better. It would be cleaner to
Yeah, do a
have
V
all the fixes.
V 1.1 patch release.
Yeah. So basically, I think these two pins are empty and they are not used on the plug-in board. So I could use this pin to the enable pin and connect this to the enable, and then pull it down by a pull down resistor and turn it only on after the ESP32 has booted up.
So remind me again, when this chip boots, you're saying it's pulling all these pins high?
No, it's so I have by default pulled it high. I've directly connected it to 5 volts because when I was because I thought, okay, the level shifters are already needed. Why would I turn the enable pins on and off? So this is like a very common. So for example, here,
Yeah.
so even
But
the
if
level
but
even
why?
the
So even the enable pin on the level shifter, even if that's on, why is any of the outputs? So I'm assuming like the inputs are on the A side and the outputs on the B side, or vice versa.
Yeah.
Why wouldn't they all just be low?
but I think the internal circuitry of this level translator is so that it will keep driving to the whatever the voltage is on B. I read something like that, but I'm not sure. But it's something like that. That the B port tracks the VCCB pin supply voltage. So basically, whatever voltage you have on VCCB, all the pins on B will try to track that unless pulled down.
And so is the problem that during boot, the A side is like floating?
Floating, maybe. Yeah. So
Yeah.
that's why it tries to go to 5 volts, and probably it goes there. Otherwise, my solution wouldn't work, right? So basically, I've disabled the enable pin, and then it doesn't track the port B or the VCCB.
Right. Yeah, I still just don't feel comfortable that I understand what the root cause is, like why the boot behavior would be weird.
So what is happening is here.
But also, you haven't written software yet to actually to run this thing, right? Or have you never written enough
yes.
to like?
Well, I just wrote a basic. So after it boots up, it stops because the ESP32 is stopping the motors. So after running for a while, it stops, right? So I'll wait.
But somehow the default before it has configured maybe it's that like in that chip, like the pull down resistors need to be configured or enabled or something, and it's floating during boot.
No, but before boot, how would you configure that?
No, I know. I guess you probably can't,
Yeah.
but I'm just wondering if that explains the behavior.
So
one way to do is like have a pull down resistors on each of these lines on the A side. So by default, they will all be low, and when the board powers up, the output is also low. So yeah, that is one way to do it. But yeah, the reference circuit did not have something like that, so I didn't put it.
Yeah.
But probably that is why they have this output enable pin. But yeah, when I was connecting all of that, I thought, okay, all the level translators will always be needed, and I didn't think about the booting problem, because generally you don't wait so long in the bootloader.
I wonder if mine will do that.
Can you explain why the existing tumbler doesn't have that problem?
Because it boots up immediately, way faster.
So what you're saying is because you're using a more sophisticated chip, It's booting up more slowly.
No.
I think the more
Uh,
sophisticated chip has configurable pull up or pull down resistors, and so they're just not configured by
yeah,
default.
but then it has to happen during the bootloader when it's in the bootloader. So it's waiting in the
Only for the
bootloader.
yeah, for yours, which is more configurable, like the ESP32 or whatever is like super configurable, and everything can
Yes.
be like rewired, right? Whereas the what's the other chip called? The normal Arduino chip. It's probably not that configurable, and maybe it just defaults has pull down resistors on all those pins, whereas the ESP32 is like, well,
Uh,
maybe you want to pull up, maybe you want to pull down. You have to decide at boot time.
no, I don't
You
think
know what I mean?
like the GPIO logic cells are so complex in either of them. So ESP32 can be done so that it boots up immediately, but it's like what kind of bootloader they have inside. So they have some bootloader inside the ROM, which you can use to reset the entire thing. If you have like Brit, and then you can use that ROM bootloader image to have the bootloader. So that can be done. So
Sure, but the default chip that's in there on the normal tumbler is what?
it's a ATmega 8-bit
Yeah.
AVR core,
So what I'm
and then
proposing is that perhaps it's not the boot time that's the difference, but it's the default configuration between an ATmega and an ESP32. Because like anytime you've got the Arduino bootloader in there, it's going to be slower than.
yeah. So I'll have to read the GPIO like cells how they are configured inside, but generally it's like floating by default because you cannot store that configuration in the without when it goes offline. So that logic
Yeah, I'm,
cells
yeah, I'm just
can
wondering
only.
if the ATmega maybe doesn't even have a configuration for that. Like that's always
No,
been
it
pulled down.
does have does have some pull ups and like pull downs that I
Hmm.
have used it. But yeah, I don't know like what kind of bootloader they have. So that I will have to check this ESP32 why it takes like so much time to boot up because you can see the LEDs on the ESP32. So when it's booting up, it will try to blink and do some color show on the RGB LEDs when it's in the bootloader mode.
So one thing it's doing is it has a color show code in the bootloader. Wonder if ChatGPT knows. Yeah, so it says that GPIOs would float during boot, except for a couple of special pins.
Actually, it can be done so that as soon as it enters the bootloader, the pins are done it like either pulled down or pulled high.
Right, so
But
it could be done really fast during the bootloader.
yes, yes. But then you will have to modify the bootloader.
Yeah, this says that, or this at least thinks that the app mega is probably the same, that it would also be floating at boot. So yeah, I guess it could be just something different in the bootloaders. Interesting. All right, well, should I run through my changes?
Yeah.
Please.
Let's see. Pull this over here. Not sure this is sure. There we go. If you can pull that up. Okay, so let me try to remember the most important thing that I fixed that I sort of caught by accident, or it was like a warning that came from the DRC check, was that it said like my pin 41 of my ESP32 wasn't connected to anything. And I didn't really think too much of it. And then I was like, wait, 41? I've got 10 pins on the left and 10 on the right. Oh, no, sorry, 20 on the left, 20 on the right. Why do I have a 41? And I think at some point during my building the custom component here, I like got off by 1 when I was counting GPI, counting pins. And so I ended up skipping pin 4, this one right here, and going straight to 5. And so then everything is off by 1. Once I figured that out, I was like, oh, all my wiring is wrong. Everything's off by 1. And it wasn't, and since the very last pin is ground, that was like the easy way to identify it. Was like, oh, I'm not even connecting this thing to ground anywhere. That's awful suspicious. So I figured out which pin was wrong, reshifted everything. Luckily, like, although all the wiring was wrong, because it was just off by 1, like the routing just barely had to change a little bit. And I was still kind of actively working on the routing anyway. So figured that one out. That would have been hard to fix by soldering. I don't think that would have happened. And then after I got everything working, I also was inspired to see if I could actually power this thing off the same battery, and if that would be like a reasonable thing to do. Because the more I thought about it, the more I was like, this sure would make it easier to make a whole other little isolated rover with just my 1 battery. So I added this in, which, so as I said in Discord, I realized that it's got a voltage regulator on board. And when I looked up the datasheet for it, it seemed like it would support fine to like 12 volts. And I'm running 6 volts anyway, so it seemed like it was going to be fine. I ended up prototyping that out with my on the breadboard, and it seems to like run fine. So I can put 6 volts in this 5-volt pin, and I still get a steady 3.3 out. So that voltage regulator must be working correctly. So then I added that, just connected that up here, and then I threw in a isolation capacitor there as well, based on Magic and Cargo Cult. But it turns out, like, based on the schematics that you have on YaRG, it looks like there is already capacitors in there, so maybe it doesn't matter. But it's already shipped, so this is what's happening. And then, okay.
Did you change the resistors on that? What is that R1 and R2 at 6 volts? It's going to GPIO 14.
So this was the other scope creep feature, which is that I wanted to be able to measure the voltage of the battery. And so this is the voltage divider that gives it about a 0.5 volt, I think, to
it should give around 0.6. Yeah.
And I also prototyped.
So is that analog to ADC pin?
That is an ADC pin, yeah.
Oh, okay.
Yeah, and that worked. I think it seemed to be off by like 20, like a pretty linear, like 20% or something. So when I wrote the code, I had to just like multiply it by some constant to get the numbers out that seemed correct.
Okay.
But I worked still. That's kind of cool. And I think that's all I had to change on the schematic. So if I flip over here to my PCB design, I did reroute everything. So from our last chat, I ended up taking the fill from the front layer, which was it was like the 6-volt fill line. I just took that out and I just routed actual thick lines for the 6-volt.
Did you make this? What is this? What is this called? This ESP32S3 room, or was it there in KiCad already?
I had to make that myself. So that's where we get into trouble with being off by 1 on pin. So this is my pin 40 that was missing here. Oh wait, is this not showing up? Why is it not showing up?
Is it possible to export the one you have made along with the footprint, so that I could use it in my board if I want to?
Yeah, I think so.
We will have to check, since you have already done it.
Yeah.
Like I could use the same component if I want to make a board for the Freenode.
Yeah, I think I can. I think I can probably export that.
Can you explain why you're using 6 volts, which appears to be a non-standard voltage?
It's the battery pack that I have for my current rover happens to be a 6-volt. It's not LiPo. It's the other kind that is less likely to burst into flames.
But if you change the battery, will that voltage measurement work? You just might have to change some constant.
I would have to change the constants because I think it should still work up to.
Yeah.
I think it can. I think that pin could actually accept up to. Actually, it can go above 3.3 volts. I think it's got. I didn't actually realize this, but the ESP32 has this like attenuation function on the ADC, so you can actually you can change the range that it's measuring pretty widely. I mean, not like up to lots and lots of volts, but it probably would be okay up to like 3 volts is probably fine. Or 3.3 volts I know is fine. Going up, I think you can actually go up a little bit more than that. And then voltage regulator seemed like it was, it had its it seemed like it was fine up to 12 volts. Although I noticed the schematic that you sent over on YaRG, it actually says on there it could be 7 to 4 or 7 to 3.3 or something is what they have. Like, I'm not exactly sure what they meant by that on the schematic, but that's what they have. So. Yeah, so then I did the rerouting. I took off the fill on the front layer so it stops complaining because it's just too hard to get contiguous fill and wasn't really that useful, especially after I flipped these chips around so I didn't have to route the power as far. And then my ground fill is kind of nice and cohesive too, so kind of in 2 parts.
So you are not having any top fill? Or?
No top fill.
Is it?
Yeah.
Okay.
Just ground fill in the back layer.
So where did you order it from?
I did Osh Park.
Osh Park.
Yeah.
So they didn't say anything about the ground fills, because when I put it on this JLC PCB, they said it needs to be filled by at least 35% or something.
Yeah, they didn't.
I had that.
No complaints, at least, but I'm pretty sure this ground fill is. Do you think they wanted a fill on both layers?
Well, I initially I didn't have much fill, and then they said your board doesn't seem to have at least 35% fill. So then I filled both sides.
Yeah, they didn't say anything about it. I wonder what the reasoning is for that, or if like when they manufacture these, are they removing copper?
There could be a reason in the
I wonder if the
manufacturing.
manufacturing reason more than like electrical reason.
Yeah, that I do not know.
But yeah, they took it, so we'll see if I don't. Maybe they have less automation. I don't know. Yeah, is there anything else notable on here? So yeah, so I had to run my 6-volt just directly up to this pin to give it power. And I think that's the only real change. And then I added some text on here. See, mine is version 1.0, so that I know that I can do a patch later when I realize what I got wrong. And if we do our 3D view here, it'll be like that, but purple. No, it doesn't show up. When I share a new window, it doesn't show up. I don't understand. Well, anyway. Hopefully it works.
I found something on the PCB fill question. The only advantage I can imagine is evenly distributed copper on the outer layer is usually advantageous for plating purposes, because it helps ending up with uniform plating thickness in all areas of the PCB.
Yeah.
Can you try to export that PCB footprint and what is it called on the schematic?
Symbol, I think.
Symbol, yes, symbol.
Yeah. Let's see if here, I will let me try this again if I can share the right. I need to share the entire screen. There we go. So my custom.
But why do you have the pins in a different order? Or is it like that on the actual Freenov board?
No,
These
so
numbers.
I thought maybe it would make more sense on the schematic to have it more semantically grouped, so you can see what. And they're numeral. They're numeric order within their kind of group, I guess. But you can kind of see like which ones are not assigned in this way.
Okay.
Because otherwise,
but it's not like this on the actual schematic, right? How is it?
What do you mean on the actual schematic?
The
one
I mean the actual
you found?
Actual Freenov, yeah.
I don't know, but I hadn't seen this because it didn't exist, except for what you have. See, this looks like the schematic for like the chip. And then this is the schematic for the headers. I'm guessing.
So how does your does it look similar? Or is it different?
It's different because
Yeah. But on the actual Freno, you have the correct pins then, is it?
on the actual Freenet. What do you mean? Like on the footprint?
So yeah, like when you plug this in, yeah, on the board, uh, how are these? How does the footprint look? Does it come out in order from 1 to 20,
Oh,
40?
yeah. So that has to be. So that's just
Okay.
two strips like this,
Yeah,
right?
yeah. So only the symbol is ordered differently.
Mhm.
The
Yeah,
footprint
I
is
mean, it kind
ordered.
of has
Yeah,
to be because the schematic. I mean, the schematic doesn't have necessarily like
yeah.
reality,
True.
right? I don't know.
Yeah.
I really like mine. Like just to have all the things associated.
Yeah, it's like easier to read.
Yeah. Yeah, and then when I used it, like
Yeah, it's easier to, I think, wire it up in the schematic if you have grouped them together. Like,
yeah. Cool. All right, let me see if I can. Keep losing the. All right, let me see if I can export this somehow. Export a symbol.
choose the library table, add the library too.
That's a good question. How does this? How are files organized? Here we go. So project files. Oh, so this is my. This is the symbol. Yes. But then where's the footprint live?
I think you can get that from the PCB editor.
But it must be also stored separately, right?
How to export?
Oh, okay. So that footprint was exported just as a file. And then no, I don't have. I was going to put it in the Yakusaur repo.
So is it a text file or something?
Oh, good question. Where did it go? Documents. understand where it went.
No. You know, we can't really see this in the recording.
Okay. It's probably for the best. Until I figure it out.
I found this like a way to export the symbols and the footprint together. I don't know. It's like
Okay, there's that. And then
So can you fill us in what's happening, because nobody can read it?
yeah, so I'm trying to just move this file. I think maybe my documents folder is something weird. So I'm just trying to put this file into the Yakusour repo, and then we can see if that helps. But yeah, so what kind of file is this? It is a text file. Oh, I don't know if that could be seen.
it's some
yeah,
sort of
yeah, some sort of markup language.
bracket-based Lisp-like
Yeah.
Script.
Yeah. Okay, so that is the footprint, and then the symbol though is, I haven't figured that part out yet. It did all right. Okay. Maybe that is the whole thing.
Can you drop that file in Discord? Maybe let's see if I can import it.
Okay. You know, why don't I even see that file? What is this thing doing? Oh. Oh, I had two. Weird. All right, so you can grab this from GitHub then. Or I can drop the link.
Did you drop the link?
I dropped it in the Discord thread.
Yeah. How was it import, right?
Yeah, probably.
No, it
Or maybe in the
was.
symbol editor.
Yeah. R selector. Not writable. Mm. Oh, nice.
Look at that collaboration.
Live. This is good. Now I don't have to make this again. Yeah.
Now we might want to see if my board works before
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 I
anyone
make.
else is serious on it.
Yeah.
So what was surprising about this transfer?
Nothing.
Sharing files is still hard. I don't know.
Well, we have never, at least I have never done it before. Or I think like together in YaRG, YaRG we haven't done this. Like hardware sharing.
Yeah, I think
We have.
like the software itself just seems. I mean, it's got all the essence of an open source project of like you're just
Yeah.
really never quite sure what strange things they've done based on the legacy of hardware design. Like,
But
what
I
kind
think
of
this is
file
the
were
first
they to
time we
use?
are sharing something in hardware, right?
Yeah, probably.
We haven't? Yeah, probably. Yeah. Yes. Maybe we end it today. Just 5 minutes left.
Yeah. Cool.
Yeah.
I felt successful.
Yeah.
Well done with the boards.
Okay.
Yeah.